All right, so welcome to 2.6, factoring expressions. We've been factoring numbers. We're going to factor expressions, and we're going to see what that's all about today. And you have to be able to do this warm-up to understand all that, so please do that. All right, so the greatest common factor is the largest number that divides into both those, and I think it's 2, but we check our work here. And yet, well, it's not. We're not simplifying a fraction here, right? The greatest common factor there is 2. The greatest common factor in this one, I believe, is 3, right? And yeah, so it was 3. All right, so now this is evaluate the expression. All right, so let's look at that. 12 plus 14. I'm asking you to do elementary school work there because I want to show you something. And so that's 26. And then this next one, well, what's the rule? You have to do inside parentheses first, 13. And then that's 2 times 13, 26. All right, so these two have the same answer. There must be some reason for that. It's the name of the lesson, factoring expressions. So do the next one if you haven't. Well, 15 plus 21 is, in fact, 36. Let's see if this is 36. You do inside parentheses first and get 12. 3 times 12, 36. So it's turning out that 15 plus 21 is the same as 3 times 5 plus 7. Well, that's interesting. And it turns out, let's look at the one above it, 12 plus 14 is the same as 2 times 6 plus 7, right? They both had this, right? Those two sides of the equal sign had the same answer, 26. Those two sides had the same answer, 36. Well, why is that? All right, we're going to see that today. But let's look. 3 times 5 is 15. 3 times 7 is 21, right? That's what, when you write this, that means multiply everything inside there. When you wrote this one, it means multiply everything inside there. So 2 times 6 is 12. 2 times 7 is 14. All right, and this is called factoring expressions. We're going to do that, in fact, backwards. Now, that was a lot to get right off the bat. I'm going to go over it more slowly in a second. All right, so can we factor more than just numbers? Yes. Okay. All right, so we want to remove the large, right? So if we had 35 fiftieths, what would be the greatest common divisor? It would be 5. Okay, so same thing here. We're going to remove 5 and then put the two numbers that are left over in the parentheses. So let's see that. So 35 divided by 5 is 7. 50 divided by 5 is 10. So here, right, we removed 5 from 35. We put 7. We remove 5 from 50, you get 10. And this is called factoring the expression, okay? And it's sort of a weird lesson because what this is trying to get you ready for something you're going to do in 7th and 8th grade. That's what this is about. It's a standard for 6th graders to be able to do it. What do you use this for? Well, you use it for something very serious in 7th and 8th grade. But here, you just have to know that those two things are equal, right? Because if you added those two up, this side adds up to 85, all right? And this side is 5 times 17. Guess what 5 times 17 is? 85. So this is the answer there. You factored the expression. All right, so let's do the next one. So out here is going to go the greatest common factor, right? If you had to simplify 90 fiftieths, what would you divide by? Well, hopefully everyone's saying 10. So that's what goes out here. Then if it's plus, you put plus. If it's minus, you put minus, right? And this simplifies to 9/5. So what you put here is 9 and 5. Right? Those are equal. Let's double check that these are equal, right? 90 minus 50 is 40. What's 9 minus 5? 4. Yeah, they're equal. 10 times 4. So this is the original expression factored, right? What were the greatest common factor was 10, and then the other factors are 9 and 5. Right? 9 is a fact. 9 and 10 are factors that make the product 90. 5 and 10 are factors that make the product 50. All right, so let's try it. We're just going to keep doing that. All right, so it says now you're going to have to show that they're equal. So let's see that. So what's the greatest common factor here? 5. We're going to take that out. 5 times what is 25? 5. It's a plus sign, so you put plus. 5 times what is 50? 10. All right, so now you're going to show they're equal. So how do you do that? Well, you add those together. Hopefully you get 75. Here, you add those together because you add what's inside parentheses, and you get 15. And then you show me that, 5 times 15 is 75. So the red is the showing that they're equal. The blue is the factoring. All right, so let's do the next one. So 33 minus 9, and be careful, you have to do a little borrowing here, right? That's 4. So that's 24, right? 24. Well, I got ahead of myself because that's not what we're doing yet. So that's equal to 24. All right, but what would be the greatest common factor of 9 and 33? Well, the greatest common factor of those is 3, right? So that's what goes out here. Sorry, I want to be consistent on my colors. So we'll do the greatest common factoring in blue. All right, so we remove the 3. That's the common factor. It's minus, so it's minus. So 3 times what makes 33? 11. 3 times what makes 9? 3. And you have factored the expression. Now we're going to do the proving, which I leapt ahead and started doing. Right? 33 minus 9 is 24. 11 minus 3 is 8. And hopefully we know that 3 times 8 is 24. So the blue is the factoring. The red is the showing they're equal. Okay. All right, so let's do this again. So it says, and show they're equivalent. Now, oh, by the way, so equivalent and equal means the same thing. They're the same number when you're doing the work. Okay, so now we have 3 numbers here, right? We haven't had 3 numbers before, but it's the same, right? 8, 4, 22. There's only one number that divides into all of those. And what is that number? It's 2, right? 2 is the largest number that divides in all 3 of those. And now you're going to have 3 numbers. So 2 times what makes 8? 4. 2 times what makes 4? 2. 2 times what makes 22? 11. We've factored it. Now we're doing the proving. 8 plus 4 is 12. 12 plus 22 is 34, right? So this side is 34. Now on this side, you do inside here first. 4 plus 2 is 6, plus 11 is 17. So you have 2 times 17, and 2 times 17 is 34. Let's do it again. All right, so I think it's pretty obvious the greatest common factor here is 5. 5 times what is 50? 10. 5 times what is 15? 3. 5 times what is 45? 9. All right, and now we're going to prove that those are in fact equal. So 50 plus 15 plus 45 on one side. 5 plus 5 is 10. 10 and 11. So this side equals 110. The other side better too. 10 plus 3 is 13, plus 9 is, what, 22? So that side is 5 times 22. And I believe that is in fact 110. And we've proved that they are equivalent. Factored expressions and the starting expression are always equal or equivalent, we say. All right, so you don't have to prove they're true anymore. It just says factor those. All right, so what's the greatest common factor of 48 and 60, right? And if you ever get confused, write it as a fraction, because you all hopefully know basic how to simplify a fraction, right? What would you divide by here? Well, 12, right? So 12 goes there. 12 times what is 48? 4. 12 times what is 60? 5. That's the answer. What's the greatest common factor of 72 and 56? They're both on the 8 times table, right? 8 times 9 is 72, and 8 times 7 is 56. All right, so we're practicing. All right, so what number goes into 42, 18, and 54? This one's considerably harder. But think about it, all right? What's the only number that divides into all of those? They're all on what times table? I think they're all on the 6 times table, right? That's the greatest common divisor. Let's see. 6 goes into 42, 7. 6 goes into 18, 3. 6 goes into 54, 9. Factored. Let's try the next one. All right, so this one's 54, 18, and 27. Well, 54 and 18 are on the 6 because we just did it. But 27 is not on the 6. All right, but there's a different number. You might think it's 3, but I think there's a bigger one than 3. I'm going to go for 9, right? 9 times 6 is 54. 9 times 2 is 18, and 9 times 3 is 27. Factoring expressions. All right, and hopefully you look at that and go, oh, that must be 25. So 25 times what, right? 8 quarters make $2. 25 times 8, and $1.25 is in fact 5 quarters. All right, good luck. So, oh, and it says show. All right, so that's the factoring. Read your homeworks. Most of the time, I don't think you have to show this, but there are a couple where you do. And so this side, 200 minus 125, borrowing, or regrouping as it's called, and that should be a 9. So this side is 75, and this side is 25 times 3, and this 25 times 3 equals 75. Yes, you've shown that they're equivalent. Good luck on the homework.